Happy day! I am Dr. Brinda Ramanujam and we are going to study about the object-oriented systems development life cycle in this session. The object-oriented systems development life cycle's goals are to check whether the software development process, the steps in the software development process, building high-quality software, building an object-oriented systems development, having a use case-driven systems development approach, building a prototype, a rapid application development, component-based development and continuous system testing. These are the goals of an object-oriented software development lifecycle process. Moving on, we will first start with the software development process. What is the software development process? The aim of software development process is mainly the transformation of the user's needs to the application and bringing a particular solution. So the essence of the development process is transformation. The user's needs are going to be transformed into a problem statement where you are going to perform the analysis. That is the first transformation. Transformation 2, the analysis is going to be converted into what is called as the design and implementation. The design and implementation is then transferred to as a software which is going to be the system software, which is nothing but the product that is going to be delivered to the customer. So the entire software development process is going to be given in a nutshell as transformation 1, transformation 2 and transformation 3. I repeat, the transformation 1 where your user's needs are going to be converted to the problem statement. The problem statement is going to be analyzed and the analysis is going to be converted to a product. This is the traditional waterfall approach. The traditional waterfall approach mainly focuses on what is to be done, how it is to be done, do it, test it and use it. So the traditional waterfall approach mainly focuses on what we have to do. What is it that we have to do to build the system? How we have to do it and how will we do it, and then test the system and do the final usage of the system. When you are using the system, you need to test whether it is working properly. Let us focus on the quality aspect of software. When we are building a software, we need to focus on the quality of the software. There are mainly two basic approaches to software quality. We can test the system according to how it has been built. And the second part, we can alternatively test the software system with respect to what it should do. So we need to test the system in two different aspects, as how we are going to build it and how it is going to work or what it is really doing when we build the software. Quality measures of software can be categorized and evaluated into 4. The first one being correspondence, the second one being correctness, the third one being verification and the fourth one being validation. Quality measures, correspondence measures how well the delivered system corresponds to the needs of the operational environment. The needs are transformed to requirements, from requirements to design, and then your system is built, which is nothing but your software. Correctness measures the consistency of the product requirements with respect to the specification or the design specification. So once your needs are converted into requirements, from requirements to design, if it is correct, that measures the correctness of the system. Verification and validation tells whether the system is being built in the right way. Verification refers to whether I am building the product right, which is nothing but predicting the correctness of the system. Validation refers to whether I am building the right product, which is nothing but predicting the correspondence. So verification phase happens with respect to the requirements and design phase, whereas validation phase happens from converting the needs to the software. The entire object-oriented systems development approach can be defined in an iterative manner. Iteration with respect to analysis, design and implementation. Let us see what are the phases in the analysis stage, what are the different phases in the design and what are the different phases in the implementation stage. In the analysis stage, we are building use cases and analyzing the objects and validating the test cases. In the design phase, we are building classes, designing classes, defining attributes, building an object, dynamic model, building the user interface and also trying to satisfy the user's tests, and check for quality assurance. The last part of your object-oriented implementation phase, where you are trying to have use case tools to implement and check whether the software is working according to the needs of the user. The entire object-oriented systems development activities can be defined and classified into different stages. One is the analysis, design, prototyping, component-based development, and incremental testing. The use case is the name for the scenario to describe the user-computer system interaction. So in my use case, I am going to identify the actors. Then I build my use case model where I am identifying my actors. Actors are represented as stick figures. The actions which the actors can perform are going to be represented as ellipses. So actors are going to be represented as stick figures. Ellipses represent actions performed by these actors. Actors are people who are part of the system, the people who are going to be using the system and the people who are going to be involved in the entire system. The use case model can further be classified into the dynamic model, the object-oriented analysis model, and testing of the use case scenarios. The entire object-oriented analysis is concerning with determining the system's requirements, identifying classes, and the relationships between the classes that make up the application. The design of object-oriented system is going to check whether the classes which you have identified are refined, designed, refining the methods, refining the structures, and refining the associations. The last part of my object-oriented design is building my user interface. User interface to check my view layer classes and design data access layer classes. A prototype is a quick and easy model which can be built to enable the user to understand the entire system. Prototype is a quick model that is built by the developer to show the functionality of the system. It enables you to understand how easy or difficult it will be to implement some of the features which the user is requesting you. The types of prototypes can be classified into 4: the horizontal prototype, vertical prototype, analysis prototype, and the domain prototype. The horizontal prototype is a simulation of the entire interface of the entire system. The vertical prototype is a subsystem of the system features with complete functionality. The analysis prototype explores the problem. The domain prototype is an aid for the incremental development process. So the incremental development is the different stages of the development are going to be shown with the help of the domain prototype. Component-based development is another approach for object-oriented software development where you have an industrialized approach. So industries which require component-based software have this approach to software development, which is nothing but my CBD, component-based development. It is an approach to software development where you focus on custom development assembly of pre-built projects, pre-built software components. They are called as legacy programs, legacy screens, legacy software packages which are available as an open connectivity which can be built as a component-based development. RAD is yet another development with respect to object-oriented software. RAD is a set of tools and techniques which help you in developing the software at a faster pace. We can do the same process at a quick and a faster pace. Does not mean that RAD is going to eliminate SDLC, but it serves as a platform to have all the SDLC inbuilt in the RAD. The incremental testing is the next part of our software development where every bit of software which we are developing in the object-oriented systems development lifecycle, we test. Testing does not wait till the last part of your software is built. It does not wait till your delivery of your software. Incremental testing happens at every stage of your software which we are building. As we are delivering software, we start testing. We do not wait till the delivery of the entire software. The software development and all of its activities, including testing, is an iterative process. Reusability and reuse strategy are one of the most important concepts with respect to object-oriented software development lifecycle. If you need to build object-oriented systems, we need to enhance and emphasize on reusability. Reusability with respect to information hiding, conformation to naming standards, creation and administration of an object repository, encouragement by strategic management, and establishing targets for reusable components. These are some of the strategies which we will implement for building reusable components. The summary is, the essence of the software process is the transformation of users' needs to a solution. The entire SDLC is an iterative process and is divided into analysis, designing, prototyping, and the final one, which is testing. Thank you.